Okay, thank you for introduction, and thank you for giving me this opportunity to present our activities related to mobile networks communications, which might seem to be quite disconnected from space communication, but in fact, in recent years, there are strong efforts, not only in the research itself, but also in standardization towards communication, not only on the ground, as you know it, with your mobile phone, but also communication in the air and in the space. Basically, satellite communication is now being introduced into the standards for mobile networks, and its further evolution is on a roadmap of standardization body for mobile networks. So I will first tell you something about our laboratory, and then I will focus on three major topics we are addressing, and I believe these are related to space. And then I will talk about some equipment and the team. So our laboratory is focused on future mobile networks. So 5G that you might hear in media, it's outdated for us. We work towards future mobile networks. And we are quite small group. It's me, 3 to 4 researchers and postdocs, plus about 5 PhD students and the same amount of master students. And we work with quite many organizations in Europe and in the world. And our main focus in the area of mobile networks, because mobile networks are quite broad topic, we are focused on aspects related to communication management. So you can imagine it's about what frequency at what time should be allocated to given communicating devices. Yeah, that's the major scope. We also deal with mobility management, if users are moving, for example, how to switch them from one base station to another. And also, 5, 6, 7 years back, we started working on communication through drones. Drones that carry communication hardware and provide connectivity in the areas that are, for example, busy for a short period or in case of emergency. So I will now go through 3 topics. The first one is related to radio resource and communication management. And in this field, recently we developed a solution that allows to significantly reduce the management overhead. Basically, if you want to manage communication and you want to make it efficient, you should be aware of channel quality between communicating devices, and not only two communicating devices, but also devices around. So we developed a solution that allows to reduce overhead that is required to acquire information about channel quality significantly, because if we measure the channel quality, it costs us energy, time, and radio resources, because we measure at the resources where we could communicate if we wouldn't measure. Yeah. So we developed a solution that is based on deep neural network, and it takes information from the network that are already known and process it and estimates channel quality. So this way we can significantly reduce cost of communication. And we also work on aspects related to mitigation of interference. If there are multiple communicating devices, then they interfere to each other if they communicate. And if you imagine this scenario where we have conventional base station communicating with users, and at the same time we have high-altitude platforms, UAVs, and satellites, and all these communicate somehow together. It can be for a purpose of exchange of data or control information or whatever. Then you need to take care of interference, and you need to find a good way how to deliver data from one point to another. So that's the topic we work on, and we started to addressing this topic from a terrestrial point of view, and then we extended it towards UAVs and satellites as well. Then about mobility management, again, we started with purely terrestrial networks 2 decades ago, almost. And we focus on the aspects related to management of switching from one base station to another to make it efficient so that users don't perceive that there is something going on in the network. And 3 years back with my PhD student, we also started addressing problem in the network where we have UAVs or high-altitude platforms that provide connectivity to the users. So now we have users that can be mobile, that can move, but at the same time, entities that provide connectivity, like drones or high-altitude platforms, can also move. So you have both ends of the communication link moving. And surprisingly, there was no work done on this topic so far in the literature. So this is something that is quite interesting topic even for the future. The third topic I would like to mention is related to edge computing. It's not native mobile network topic, but it's the topic that we started more than 10 years ago in frame of a quite successful European project. And within this project, we were basically the first consortium that demonstrated possibility to offload computation from energy-constrained devices to some servers that are collocated with base station of mobile network, so that you can reach low latency, and at the same time, you can save the energy consumption of the devices. For example, in your mobile phone, you run some computing demanding application like a game, and instead of the processing behind the game being done at the mobile phone, you can offload it to a base station. And if the communication channel is of good quality, it can be energy efficient, and it can be even faster than in mobile phone. And now the challenge is to take these computing resources, deploy it to flying objects like satellites, UAVs, or whatever, which are naturally energy constrained, and you don't want to make them too heavy, right? So first challenge is what's the amount of computing power I should deploy on UAV, and then you don't want to spend energy for computation that might be done somewhere else. So another challenge is to allocate computing resources at the time and at the place where it is beneficial from the perspective of energy constraint. So now about laboratory. Our laboratory is located just over there in the 5th floor, and it's basically software-defined mobile network. So we don't have commercial equipment. We have like computers where software that emulates exactly the standard is run. There are some specific pieces of equipment that manage transmission and reception of the signal. And this allows us to emulate 4G, 5G mobile networks, and even any other functionalities beyond 5G. So for example, we can emulate their satellite communication through mobile networks. Then I have one short slide from my colleagues, because there is activity related to quantum communications at the faculty, and there is a new lab which is now being equipped and is located at our department. So it might be it's related to security mainly, and it might be relevant for the space activities, because of course security is one of key aspects. And this lab should be done in 1 or 2 years. And there are some aspects where I expect to collaborate with my colleagues in terms of delivery and distribution of the keys among different entities, including entities in the space, for example. Okay, and this is just about the team, so I guess this is me. This is my colleague Pavel Mach. You can find details at this link at the bottom if you would be interested. So that's all. Thank you for your attention.